All right, welcome back to what are definitely good choices. I'm gonna check the white noise. Perfect, really crystal clean. Mic looks good, so let's move on. And we're very near to closing this out and actually taking the exam. So we finished 104.2 mega lesson, but we were able to do it in just two parts. I believe. Let me check that. Maybe I. Oh, right, because we made this mammoth video of like 2 hours, and just closed it all out. So yeah, so now we're on 104.3, which means we only have one, two, three, four to complete, and we should get this done, and then have only three after that. So this one looks like a pretty small one, so we should be able to get this done. And yeah, think about scheduling the test. So what I'm gonna do is I'm gonna finish everything, schedule the test, and then in the, I don't know, it'll be like a week, maybe a few weeks. Then I'll go back through, and I didn't click on this section. I just went right to the lesson. So I'll go back through and I'll click on these sections, and then I'll just like remind myself of what I learned. So uh like the key knowledge areas, like understanding the MBR and GPT, partition tables, using various MKF commands. So I'll read all of these out loud, as many as I get to before the exam date. Probably get to them all. I'll go on the AI and get ask for like some test questions, and then maybe even load it up in the Anki and do it that way. So once I finish all this reading, we still got some work to do, just some basic test prep stuff, and we can ask the AI. Um, so, like, what is the best way to use 2 weeks or so to prep for a test if you've finished reading all of the testing materials? So, like, we can incorporate AI into the testing strategy. So, yeah, so we need to take like our own practice test. We need to yeah, mix the subjects. So the most recent one we will have is these last ones. So we need to go back and review the ones we haven't looked at for a while. Yeah, Anki practice tests, real world problems if we can find, spending time on the lab. I wish I could do more stuff like this. I don't know. I just never really caught on to things like mind maps. I tried, but it's like, I don't know. It just doesn't stick for me. 'Cause sometimes it feels like a form of procrastination. But hey, well, speaking of which, I'm way off topic. So let's bang this out and get closer to the test date. So, uh, so we're on dot three. We're still learning about devices, Linux file systems, and file system hierarchy standard. Um, yep. So we learned about creating partitions and file systems in the last one. Now we're learning about um, uh, control mounting and unmounting of file systems. So the last lesson was also in the topic of devices, Linux file system hierarchy standard. So I don't think we've gotten to this file system hierarchy standard yet. We'll probably get there later. So that's what was confusing me, is I wasn't recognizing this. So we'll probably get to that soon. All right, so introduction. Up until now, you learned how to partition disks and how to create and maintain file systems on them. However, before a file system can be accessed on Linux, it needs to be mounted. This means attaching the file system to a specific point in your system's directory tree called a mount point. File systems can be mounted manually or automatically, and there are many ways to do this. We will learn about some of them in this lesson. All right, so file systems can be mounted automatically or manually. And the last one, we learned a little bit about this. We learned about some ways you can use a utility to change the way to change the count for like how many times it's been mounted. But we didn't get to mounting specifically yet until now. So this section is mounting and unmounting file systems. The command to manually mount a file system is called mount. Good. And its syntax is mount dash T for type of file system, then the device where the file system resides, and then the mount point. So where type is the type of file system being mounted, for example, ext4, btrfs, exfat, etc. Then type is the name of the partition containing the file system, for example, /dev/sdb1. And then mount point, where the file system will be mounted. The mounted on directory need not be empty, although it must exist. Any files in it, however, will be inaccessible by name while the mount point while the file system is mounted. Okay, so if you have a directory and it has other stuff in it, you can still mount a file system to that directory and then look inside the file system. But then you lock out the ability to look inside other files in that directory. So it doesn't have to be empty, but it's probably best practice to have it be empty so that you can access the other files in it. So it doesn't have to be, but I would say it's best practice. Alright, so for example, to mount a USB flash drive containing an exfat file system located on /dev/sdb1 to a directory called flash under your home directory, you can use mount-t exfat/dev/sdb1 and then home/flash/. So this is for mounting a USB drive. Tip: many Linux systems use the bash shell, and on those the tilde, which is this squiggly character here, on the path to the mount point is a shorthand for the current user's home directory. If the current user is named John, for example, it will be replaced by /home/John. After mounting, the contents of the file system will be accessible after tilde/flash directory, under the tilde/flash directory. So here we go. Now we can see the contents of the USB drive. All right, so listing mounted file systems. If you just type mount, you will get a list of all the file systems currently mounted on your system. This list can be quite large because in addition to the disks attached to your system, it also contains a number of runtime file systems in memory that serve various purposes. To filter the output, you use the -t parameter to list only file systems of the corresponding type, like below. So let's pull up my lab. And let's use the mount command to see all the various file systems. All right, we can see we got quite a few. In fact, far too many. So let's filter it down to make it easier. Let's look at the ext4 file systems only. And there we go. Now the output is much easier to look at. So you can specify multiple file systems at once by separating them with a comma. Alright, so let's take a look at a different kind of file system. So this looks like an SHM file system. I'm not sure. Well, it says of type. So these are probably the labels. I'm not sure what's going on there. Let's try proc. Oh, okay, yeah. So there is one. So we'll try proc and we'll try ext4, and there we go. Now we got both of those. So you can specify multiple file systems at once by separating them with a comma, as we saw. In the output in the examples above can be described in the format. Okay, here we go. So source on target, type, options, where source is the partition which contains the file system, target is the directory where it is mounted, type is the file system type, and options are the options passed to the mount command at at mount time. So this is important to know. Proc is not a file system. Oh, well, okay. It gets. Oh yeah, no proc. So it gets confusing because proc is a file system. We can see the type is there. So I'm gonna ask the AI about this because I'm just curious to see what it's gonna say. So I'll put in the output from my lab. Then uh I will put this in there. And then I will ask it, is proc a file system?
Yes,
Okay,
proc is a
it
special file system
is.
in Linux called the proc file system. It doesn't represent a block device like x4 file systems do, but rather it's a virtual file system provided by the kernel.
Okay.
The proc file system is mounted to proc by the system and is used to expose information about processes and other system information in a hierarchical file like structured user space. The proc file system serves several purposes. 1. Yes, proc is a special file system in Linux called the proc file system.
Sometimes my reading, my thing here fails. But, I mean, that's all we need to know. Like, yeah, and because it's a virtual file system, it does not have a source as a block file system. So the source, let's see here. So it'll be source on target. So the source is just going to be proc, whereas like for the ext4, the source will be the partition it's on. But since it's virtual, it's proc. All right, and there's other virtual ones as well. It looks like this sys file system is virtual as well. Um, UDEV, that's interesting. It looks like it's possibly virtual. I'm not sure how to tell for sure whether it's virtual or not. I'm assuming that if as long as you don't have a partition, it's probably safe to assume it's virtual. Let me ask the AI. So how could you know if a file system is virtual or not from this output? Is it just by nature of the source not being a path to a partition is how you can tell, or is there another way to tell?
The nature of the source and the mount output can often give you a clue about whether a file system is virtual. Virtual file systems like proc, SYSFS, TMPFS, and others typically do not have a source representing a block device or partition, as you noted.
Right.
Here are a few ways to identify virtual file systems. Source name. Virtual file systems often have a source that is not a path to a device, e.g.
All right, so that's fair. I was worried about that. All right, so moving on. So we're all the way down to this part. Additional command line parameters. There are many command line parameters that can be used with mount. Some of the most used ones are -a. This will mount all file systems listed in the file /etc/fs tab. More on that in the next section. -o or -- options. This will pass a list of comma separated mount options to the mount command, which can change how the file system will be mounted. These will also be discussed alongside /etc/fstab. -r or -ro. This will mount the file system as read only. -w or -rw. This will mount the file system as writable. To unmount a file system, use the umount command followed by the device name or the mount point. Considering the example above, the commands below are interchangeable. So umount. Okay, so you can have instead of having the mount point. Um, so when you use the umount command, you can either give it the mount point, which is here tilde/flash, or the device name where that file system exists /dev/sdb1. Some of the command line parameters to umount are -a. This will unmount all systems listed in slash /etc/fs tab, all file systems. /f, this will force the unmounting of a file system. This may be useful if you mounted a remote file system that has become unreachable. And then -r, if the file system cannot be unmounted, this will try to make it read-only. Dealing with open files. When unmounting a file system, you may encounter an error message stating that the target is busy. This will happen if any files on the file system are open. However, it may not be immediately obvious where an open file is located or what is accessing the file system. In such cases, you may use the lsof command, so list of open files, followed by the name of the device containing the file system to see a list of such processes accessing it and which files are open. For example, we try to unmount this, but the target is busy, so we go lsof on the target, and we see, oh, we've got a PDF file that is open. So you can run a kill on the process ID, and then you can unmount the file. So let's do a lsof in my home lab and see if anything's open. Oh, we got all sorts of things open. Wow. Okay. And we can do a lsof and then to redirect that standard output or standard error into dev null. But we still got a load of stuff. So let's just do a pipe head and just see the first 10. And there we go. We've got all kinds of open files, which is interesting. So command right here is the name of the executable that opened the files. Let's take a look at my executables, systemd, all sorts of different ones. And PID is the process number. And one thing is we have this open. Let's try closing this. I don't need it open, so we're going to stop all these devices. I've got everything saved and ready to go. Then we'll close it. All right, and then let's do lsof again, and we'll do it the same way. Interesting. So, yeah, that didn't really seem to make a difference. It looks like there's a lot of open files, and it didn't really depend on GNS being open or not. All right, so command is the name of the executable that opened the file, in this case events, and PID is the process number. Name, which we see here at the end, is the name of the file that is open. So it's spilled over here. In the example above, the file magpi40.pdf is opened by the program events a PDF viewer. If we close the program, then we will be able to unmount the file system. And how do we close the program? Well, you can close it however you'd like, or you can kill the process. All right, so note, before the lsof output appears, GNOME users may see a warning message in the terminal window. So LSOF warning can't stat. The file system output information may be incomplete. So I don't think I have that. Let's try that. So I have so I'd have to get rid of the redirect of the standard output. So or redirect of the standard error. Um, I guess we could redirect the standard error to T and then see I'm trying to get the I'm trying to redirect the standard output to dev null. And then only get the... Oh, is that the input? Yeah, okay. So I'm trying to... Yeah, so I think 0 is the input, and then 1 is the output. But I'm trying to do it so that only the errors show up here, and I believe this is how to do that. So like, for example, if I try to do a cat doesn't exist, and then I do it like this. Now I only get the error. It'll be the same if I do a 0. Yeah. But if I do the 2, now I don't get any output because this is an error message. Alright, so LSOF tries to process all mounted file systems. This warning message is raised because LSOF has encountered a GNOME virtual file system, GVFS. This is a special case of a file system in the user space, FUSE. It acts as a bridge between GNOME, its APIs, and the kernel. No one, not even root, can access one of these file systems apart from the owner who mounted it, in this case, GNOME. You can ignore this warning. Alright. Okay, so where to mount? You can mount a file system anywhere you want. However, there are some good practices that should be followed to make system administration easier. Traditionally, /mount was the directory under which all external devices would be mounted, and a number of pre-configured anchor points for common devices like CD-ROM drives /mount/CD-ROM and floppy disks /mount/floppy existed under it. This has been superseded by /media, which is now the default mount point for any user removable media, for example, external disks, USB flash drives, memory card readers, etc., connected to the system. And let's see if my home lab has one. I think it does. Yeah. I'm just wondering if I have a drive plugged in. But anyways, that's kind of a tangent. On most modern Linux distributions and desktop environments, removable devices are automatically mounted under /media/user/label when connected to the file system, where user is the username and label is the device label. For example, a USB flash drive with the label flash drive connected by the user John would be mounted under /media/John/flash drive. The way this is handled is different depending on the desktop environment. That being said, whenever you need to manually mount a file system, it is good practice to mount it under /mount. Mounting file systems on boot up. The file /etc/fstab contains descriptions about the file systems that can be mounted. This is a text file where each line describes a file system to be mounted with 6 fields per line in the following order: file system, mount point, type, options, dump, and pass. Where file system, the device containing the file system to be mounted. Instead of the device, you can specify the UUID or label of the partition, something which we will discuss later on. The mount point, where the file system will be mounted. The type, which is the file system type. Options, mount options that will be passed to mount. Dump, which indicates whether any ext2, 3, or 4 file systems should be considered for backup by the dump command. Usually it is 0, meaning they should be ignored. Pass, when non-zero, defines the order in which the file systems will be checked on boot up. Usually it is 0. For example, the first partition on the first disk of a machine could be described as /dev/sda1, and then the mount point is here, and then the type is ext4, and then these are the options: no a time, and then errors. The mount options on options are a comma separated list of parameters which can be generic or file system specific. Among the generic ones we have a time and no a time. In this case we have no a time. By default, every time a file is read, the access time information is updated. Disabling this with no a time can speed up disk A/O input output. Do not confuse this with the modification time, which is updated every time a file is written to. Alright, so the next one is auto and no auto. Whether a file system can or can not be mounted automatically with mount-A. The next is defaults. This will pass the options RW, SUID, DEV, E, XEC, auto, no user, and async to mount. Dev and no dev. Whether character or block devices in the mounted file system should be interpreted. Then exec, and no exec. Allow or deny permission to execute binaries on the file system. User and no user. Allows or not an ordinary user to mount the file system. Group allows a user to mount the file system if the user belongs to the same group which owns the device containing it. Owner allows a user to mount a file system if the user owns the device containing it. SUID and no SUID, allow it or not. SETUID and SETGID, bits to take effect. RO and RW, mount a file system as read-only or writable. Remount. This will attempt to remount an already mounted file system. This is not used on /etc/fstab, but as a parameter to mount -O. For example, to remount the already mounted partition /dev/sdb1 as read-only, you could use the command mount -O remount RO /dev/sdb1. When remounting, you do not need to specify the file system type, only the device name or the mount point. Alright, sync and async. Whether to do all I/O operations to the file system synchronously or asynchronously, async is usually the default. The manual page for mount warns that using sync on media with a limited number of write cycles, like flash drives or memory cards, may shorten the lifespan of the device. Alright, so using UUIDs and labels, specifying the name of the device containing the file system to mount may introduce some problems. Sometimes the same device name may be assigned to another device depending on when or where it was connected to your system. For example, a USB flash drive on /dev/SDB1 may be assigned to /dev/SDC1 if plugged in another port or after another flash drive. One way to avoid this Oh, I see. Okay. Interesting. One way to avoid this is to specify the label or UUID, universally unique identifier, of the volume. Both are specified when the file system is created and will not change unless the file system is destroyed or manually assigned a new label or UUID. The command lsblk can be used to query about a file system and find out the label and UUID associated with it. To do this, use the -f parameter followed by the device name. So lsblk-f/dev/sda1. There we go. Looks good to me. Here's the meaning of each column. Name, name of the device containing the file system type, ext4 default Linux type there. Label, the file system label, so this does not have a name. UUID, universally unique identifier, UUID assigned to the file system, so this is GPT type, not MBR type of partition. FS avail, how much space is available on the file system. So we got quite a bit there. FS usage percentage of the file system. So 33%, not that much. And then mount point, where the file system is mounted. And it's mounted on root. In the /etc/f stab in /fc/f stab, a device can be specified by its UUID with the UUID equals option followed by the UUID, or with label equals followed by the label. So instead of /dev/sda1 and then a slash and then ext4 and then no a time comma errors, you would use so you can specify with the UUID option. So here we're specifying with the device it's on, and by device they mean partition, but you might have to dig around to figure out what this is, depending on where you plug it in on the PC. But if you know the just specific UUID or label name of the file system you're going after, you can enter that here instead of the device. So everything looks exactly the same. It's just we're using a specific non-changing identifier for the file system. And I think it's even easier because you can see the persistent non-changing identifier for the file system in the fstab file. Yeah, so we can see, let's see here. Yeah, so we've got the UUID here, I believe. Actually, I'm surprised that there's like J's and V's because it should be hex. So this is definitely a UUID here. I'm not sure what's going on here. I mean, it's a virtualized drive, so it's going to be a little bit wonky. That's like LPIC-3 stuff. Alright, so moving on. Okay, so that's the mount point, so you use that. So, or if you have a disk labeled home disk, then you do label equal, and you don't have to put in this big string here, and you don't have to go digging around to see what appliance it happens to be on. And then everything here would be the same if it wasn't different. In this case, we were using different options. We do have the same file system, but we're mounting it to a different mount point. The same syntax can be used with the mount command. Instead of the device name, pass the UUID or label. For example, to mount an external NTFS disk with the UUID here, which is an interesting UUID because it does not have 128 bits, it looks like, and it doesn't have the dashes syntax. So I think this is just the last portion of the UUID. Not really sure what's going on here. On /mount/external, the command would be mount -t ntfs UUID equals, and I guess you can pass in the last portion of the UUID. Let's check that with the AI. Okay, so what we're going to say is the syntax of the UID looks incorrect to me. Is this the full UID or an acceptable abbreviation of it? All right, we'll have it read it.
You are correct. The UUID syntax provided
Oh,
in
it's
the content
incorrect?
appears to be an incorrect abbreviation.
Oh, it's incorrect. Okay.
A full
Wow.
UUID typically consists of 36 characters in the form of 8 groups separated by
Yeah.
hyphens, like this. 1 2 3 A 4 5 6 7 E 8
Oh,
9
it's
B
just
1
a
2 D
failure.
3 A 4 5 6 4 2 6 6 5 5 4 4 0 0 0 0. The UUID in the provided content, 56C11 DCC5 D2 E1334, does not follow the standard UUID format. It seems to be a shortened or truncated version of a UUID. To use the mount command with a UUID, you should provide the full UUID in the correct format.
Oh, really? Okay.
For example, bash $mount TNTFS UUID equals.
We don't have to hear the full ID read out loud, but okay. So that's good to know. If this doesn't work, so just put the full one in there. You have it. You know, you can copy paste it probably pretty easily. So don't get tricked by this. It looks like it's a typo. Enter in the full GUID. All right, so mounting disks with systemd. Systemd is the init process, the first process to run on many Linux distributions. It is responsible for spawning other processes, starting services, and bootstrapping the system. Among many other tasks, systemd can also be used to manage the mounting and auto mounting of file systems. To use this feature of systemd, you need to create a configuration file called a mount unit. Each volume to be mounted gets its own mount unit, and they need to be placed in /etc/systemd/system. Mount units are simple text files with the .mount extension. The basic format is shown below. So we've got units, mounts, and install, description, what, where, type, options, and wanted by. So description is a short description of the mount unit, something like mounts the backup disk. Then what should be mounted? The volume must be specified as /dev/disk/by UUID/vol UUID where vol UUID is the UUID of the volume, and then where should be the full path to where the volume should be mounted, and then type, the file system type, options, which are mount options that you may wish to pass. These are the same used with the mount command or in /etc/fstab. Wanted by, used for dependency management. In this case, we will use multi-user.target, which means that whenever the system boots into a multi-user environment, and remember that the runtime types, I remember that a bit. There's 0, 1, 3 is the multi-user environment. A normal boot, the unit will be mounted. Our previous example of the external disk could be written as, then we have unit mount install. So based on these things that we went with external data disk for our description. We saw that up here. Oh, wait. Oh, no. So we're not going with what was in here. We're just making a new one. So in this case, we have an external data disk. So we describe that here. And then what it is, it's by UUID. Now here's another, this is not a, oh, you know what? The other thing is, like, this is a UUID. Is that different from a GUID? Let me ask the, oh, yeah, they're getting it twisted here because I can't tell if this is a UUID, which is something. Yeah, so this is a UUID. Is that the same as a GUID? And does it have the same syntax? I mean, because here they're getting the syntax conflated. So let me ask the AI about, and we can do that in the main one. What is the difference between a GUID and a UUID?
A GUID, globally unique identifier, and a UUID, universally unique identifier, are essentially the same thing. Both are a sequence of characters that are used to uniquely identify something. The terms are often used interchangeably, but they originate from different specifications. UUID. The term UUID comes from the original specification in the RFC 4122 standard. It is a 128-bit number used to uniquely identify some object or entity on the internet. UUIDs have 5 different versions, each using various methods for generating uniqueness, such as using the current time, the computer's MAC address, or random values. GUID. The term GUID is Microsoft's implementation of the UUID standard. It is also a 128-bit number used to uniquely identify objects. GUIDs are used extensively in Microsoft's COM, DCOM, Component Object Model, Distributed Component Object Model technologies, and are also used as identifiers in many other Microsoft technologies. The difference, then, is more historical and contextual rather than technical. A GUID is...
I think it might have hallucinated that, because I don't remember anything about the GUID being Microsoft specific. Is a GUID Microsoft specific? Yeah.
No, a GUID, globally
it's
unique identifier, is not
it's,
specific to Microsoft.
It's giving two different answers. So 4122. I mean, it gives me the RFC, which is important. So we should see, yeah, the layout. So like, we should 128 bit should match on here. Yeah, UU at 128 bits. So yeah, UUID and a GUID are interchangeable terms. Let's see if GUID. Yeah, GUID actually knows. So this specification defines a uniform resource namespace for UUIDs, universal unique identifier, also known as GUIDs, globally unique identifier. So they're one in the same. All right, so they have the same syntax. So therefore, I think I can safely say there is an error in this documentation. It's not the first one, or in this learning material. It's not the first one. We've seen multiple before, but be aware that this might not go here. You might need a valid UUID string, which is 128 bits separated by dashes, and it's separated by dashes in a special way, not in a pattern that is not in a repeating pattern. Okay, so where are we at now? Okay, I think, yeah. So we're reading through this. So we got the external data disk. Then the mount point. What is the mount point? Well, it's by the UUID, which is not going to be this. It's going to be in that special UUID syntax described in this RFC. So this is just a placeholder example that doesn't have the right syntax. Then where is it going to be mounted? It's going to be mounted in /mount/external. What type will be the file system? Will be NTFS, which I think is typical for an external drive. And then just the default options. And it's going to be wanted by multi-user.target. So this should look familiar too. This is the runtime setting. So basically it's wanted by the booted up computer that has all of the internet components booted up as well. But we are not done yet. To work correctly, the mount unit must have the same name as the mount point. In this case, the mount point is /mount/external. So the file should be named mount/external.mount. After that, you need to restart the system daemon with the systemctl command and start the unit. So systemctl daemon/reload, systemctl start mount external.mount. Now the contents of the external disk should be available on /mount/external. You can check the status of the mounting with the command systemctl status mount/external.mount, like below. So let's take a look at the status of the mounting. Now this is for something that's mounted. Let's see if anything's mounted in my home lab. All right, so we've got a few things that are mounted. So let's check the status on each of them. Let's check the status on the first one, which is SDA3.mount. Okay, so let's just do it without the dot mount. Okay, maybe we need to do a / SDA3 like this. Dot mount. Okay, so I don't think the status of the mount can be checked because I don't think it is mounted. Let's try it for the other one. Okay, and I think it's the same deal. Yeah, same deal there. So I think we can't even check the status because it's not mounted. All right, systemctl status mount-external.mount. So it's loaded. It's active. So it is mounted. Yeah. The systemctl start mount-external.mount command will only enable the unit for the current session. If you want to enable it on every boot, replace start with enable. Okay, so systemctl enable mnt dash external dot mount. Okay, so auto mounting a mount. Oh, okay, oh, good. I feel better now. Okay, so auto mounting a mount point. Mount points can be auto mounted whenever the mount point is accessed. To do this, you need an, which I guess makes sense because there's an A, but it's after this dot auto mount file alongside the dot mount file describing the unit. The basic format is unit auto mount install and then description where wanted by, and again this should be very familiar. So like before, description equals is a short description of the file, and where equals is the mount point. For example, a dot auto mount file for our previous example would be unit description auto mount for the external data disk, auto mount where equals slash mount slash external, install wanted by equals multi-user dot target. Save the file with the same name as the mount point, in this case mount dash external dot mount point. Reload systemd and start the unit. So systemctl daemon dash reload systemctl start mount dash external dot auto mount. Now whenever the slash mount slash external directory is accessed, the disk will be mounted. Like before, to enable the auto mount on every boot, you would use systemctl enable mount dash external dot auto mount. So like one thing is like, why do you need to mount? Let me just ask it about like all of this. So like, why do you need to mount? It's just like where to mount, what to mount, but I want to know why you need to mount. So I mean, here's the answer. To access it, it can't be accessed if it's not mounted. So mounting is a critical process in operating systems that enables the efficient and organized access to data stored on various storage devices. So you have to mount it in order to access the file systems. So how do I check? How can I check if my file systems are mounted or not? And it should be LSBLK, right? So, oh, using the mount command. Okay, so let's try that. Oh, okay. So I do have, yeah, I do have them mounted. Yeah. And I can do, oh, wait. That, what? Oh, no, it's ext, yeah. So if I do a lsblk. Oh, no, I do have a, oh, wait. But my SDA3 isn't mounted and I can still access it. What is happening? Oh, because of my LVM configuration? Oh, because it's virtual. See, it's all gonna get screwed up. That's what's kind of frustrating sometimes. Is like when you learn the basics, you're like doing your LPIC-1 or even like your CCNA. It's like, and then you go on the job. It's like these CCIE, top level concepts are just ubiquitous. It's not like you earn your CCNA, you go to an entry level position, and you only see entry level stuff. It's like, no, you're just flooded and inundated with all the advanced stuff, and like so much to the point where like none of the stuff you learn makes sense in the context of it being a part of the advanced thing. Like sometimes the advanced thing, when it's like virtualizing something, it kind of throws out the window everything you learned. Like a great example of that is like layer 2 in SD-WAN. Like SD-WAN kind of changes everything you learned about layer 2. All right, but that's the end of the reading. Let's try to finish up the guided exercises. Hopefully they go quick. I want to knock out this whole thing. Let's take a look at the clock. Well, we're at about an hour, but I think I can do it. So, guided exercises. The first guided exercise, using mount. How can you mount an ext4 file system on /dev/sdc1 to /mount/external as read-only using the no, atime, and async options. So, let's try it. So we're going to do mount -- help. So it would be mount, and then it would be, then we need to, so let's look at the syntax. So feed it some options, then we do source and directory. ext file system. All right. Well, if we look, it's like it's right here. It's where we learned about mount. Yeah, so it'd be -t for yeah, the type. So ext. So it'd be this. It'd be mount -t ext4, I believe. And then /dev/sdc1 /external read only. That's interesting. That's interesting. So we got to do a -r as well somewhere. Let's put it right here. Okay, and then the last one will be the options. And then async. Alright, so this is my answer. I'm not quite sticking to it yet. So UUID would be the, yep, there we go. Okay, so now I'm sticking to it. Let's see if it matches exactly. It does not. So let's see what the difference is between what I got and what they got. Oh, okay. So you have to. I see. Okay, so I think you can do it with -r. That's totally fine. but you do have to have the -O for the options. So I think just having it be an option is probably a better way to do it. So there you go. That's an option. -T. And then you put the options here. So the first option is the file system. The second option is the attributes of the file system. And then the where the device that it resides on, and then where you want to mount it. All right, so I got that one wrong, but yep, the real answer isn't that hard to wrap my head around. So the next one, when unmounting a file system at /dev/sdd2, you get the target is busy error message. So that means there's an open file. So how can you find out which files on the file system are open and which processes open them? LSOF. Use of LSOF followed by the device name. Oh, I kind of got that wrong. So yeah, you got to feed it the device name. So I kind of got half credit on that one. All right, so consider the following entry in /etc/fstab. So here we go. We've got a file system table entered here. Will this file system be mounted if the command mount -A is issued? Why? So it does have a no auto. So maybe that could be a reason why not. So let's look at the man page. Okay. Don't see anything there. I'm going to say no because it has the no auto flag applied to it. So it will not be mounted. The key is no auto parameter, which means this entry will be ignored by mount -A. Got it. Full credit. All right, so next one, how can you find out the UUID of a file system under /dev/sdb1? And my answer for that is you can look at the file system table. So you can do cat etc fstab. And then you can do all pipe, you can do a pipe grep on dev SDB1. I don't have that. I'll do it on SDA2. Okay, SDA1. Or you can do like a pipe less and then search for it. Yeah. So that's my answer, and I'm sticking to it. You check the file system table. Oh, got it wrong. So you use lsblock-f followed by the file system name. Okay, so let's ask the AI about that. We're going to say my answer was that you check. Okay, so my answer was that you check the contents of Etsy fstab. What was I fundamentally misunderstanding so that I gave this totally incorrect answer?
Your initial answer about checking the contents of /etc/stab to find the UUID of a file system, /dev/sdb1, is not entirely incorrect, but it doesn't directly answer the question as asked. It's a different approach to finding UUID
Oh, so it
information
was
for
kind of
mounted
right.
file systems, and it's related to the configuration of file systems in the system. In the context of the original question, the aim was to determine the UUID of a specific file system located at
Yeah, okay.
/dev/sdb1, and the lsblkf/dev/sdb1 command is a more direct and specific way to achieve that. This command provides real-time information about the specified block device or file system, including its UUID, without requiring you to look into configuration files like /etc/stab. Checking /etc/stab is a valid approach when you want to see which file systems are configured to be mounted at boot time or understand the file systems that the system is set up to use. It's a crucial file for managing file system mounts and their options. However, it doesn't directly answer the question of how to find the UUID of a specific file system, /dev/sdb1, that might be mounted or unmounted at any given time. In summary, your answer wasn't incorrect in the sense that /etc/stab can provide UUID information, but it was not the most direct and real-time method to find the UUID of a file system at /dev/sdb1, which the original question was asking for.
Okay, so yeah, I guess there's an argument that I could get partial credit for that, but definitely not an argument that I could get full credit. My answer gave it for everything, not for that specific one. And then it wasn't a direct, easy, clear, scriptable way to do it, like just entering that ls-block-f command. So how can you use mount to remount as read-only an exFAT file system with the UUID this mounted there? So so you can remount it. So let's take a look at mount. Let's do the man page for mount. And then we'll do remount. Okay, so all right. Remount part of the remount is relay. Okay, so remount file systems, combine old directory, new directory. So I think we can do the bind, remount dash bind. Oh, we can also do an alternative with a -o. I'm gonna go with the dash bind. So it'll be oh, here's a remount. So attempt to remount. This will remount option. Yeah, so actually I think I'm gonna pass it with the remount option. So let's do this. Let's do mount -o RO and then remount, I think it was. And then UUID equals that, and then /mnt/data. Let's see if that is correct. Okay, so since the file system is mounted, you do not need to worry about the file system type or the ID. So partial credit, not full credit. Just use the remount option with the RO read-only parameter and the mount point. Okay, so there we go. Didn't get it right because I included that. But, you know, if it's acceptable, then it works anyway. So partial credit might get an argument for that. But the last guided exercise, how can you get a list of all ext3 and NTFS file systems currently mounted on a file system? So you can currently mounted. Okay, so you mount dash dash a dash dash help. So let's do a man unmount, because sometimes you can get the related commands. Yeah, so C also, I think would be a good one. So, find mount, you mount. I feel like ls block is a good one. So is there like an option for mounted? Let's do a man on ls block. Alright, so currently mounted on a file system. So how can you... I think I'm going to go with... I think I'm going to go with ls block because... Yeah, because you can see the mount point. So I'm going to go with ls block, and then if there's no mount point, then I think it's safe to assume it's not mounted. Ah, shoot. Okay. So you use mount dash T followed by a comma separated. Oh, list of, so yeah, this is a bad answer because we don't narrow it down like it says. So, I should have seen that, because if I do a help on mount, then we can see the dash T probably standing for like table. I don't even know. Oh, for types. Now we can see the file system types. I just thought like mount was to like actually mount it and not to just like see the ones that are mounted. But I guess you have to pass it the syntax of actually mounting a file system, because we're not even passing it a device where a file system resides. So like it's not gonna try to mount it. Alright, so that makes sense to me. Moving on to the explorational exercises. Consider the following entry in /etc/fstab, which is /dev/sdc1, which is the device where the file system resides, slash backup, which is where it is mounted, ext4, which is the type of file system, and then no atime, comma no user, comma async, which are the file system options. Can a user mount this file system with the command mount /backup? And I'm gonna say yeah, absolutely it can, because it's okay if the file already exists. Oh shoot, okay. So no, the parameter no user will not allow ordinary users to mount this file system. So that's kind of a problem. Shouldn't really jump to conclusions until you do a man on a yeah. All right, so got it wrong. The answer is no because of this no user option here. So if we can see that with mount. So if we do a man mount, Because what the fstab is it's just a file of preloaded mount commands basically. So just like the mount command goes through and takes each line of the fstab file and then runs it against it. So like we're talking about the mount command when we talk about fstab. So if we look at no user, yeah, so forbidden ordinary user to mount the file system. This is the default. It does not imply any other options. Okay, so number 2, consider a remote file system mounted at /mount/server, which has become unreachable due to a loss of network connectivity. How could you force it to be unmounted or mounted as read-only if this is not possible? Wait, what? And it's unreachable? Then you can't... What do you mean? Do you have access to it, or are you SSHing into it? Okay, well, let's assume that they're saying that like this is an e-commerce site and they can't reach your customers can't reach it. So like you as somebody to access with this server, how can you unmount? Yeah, what can you do to unmount that? So I think it would be umount dash help. So maybe like a -F on it. Now that's a NTF file system. All right, so yeah, let's try that. We'll do the -F option. I mean, it says it right there. How do you force it to be unmounted? -F. That's my answer. Or -force. Yep. So past the -F. Oh, and I got it wrong. And the -R. So -R is read only. To unmount, the command will be unmount -F-R /mount/server. Now, yeah, so the perspective of this question is people are trying to remotely come in and access this, but you have access to it through console or through your local area network or whatever. Um, so like what do you do to unmount the drive or mount it as read-only for whatever reason you would want to do that? And the answer is you use the umount command and you pass it $f and $r separately. Remember, you can group parameters, so unmount -fr, you don't have to do it separately, also would work. All right, good. All right, so that brings us to number 3. Write a /etc/fstab entry that would mount a better FS volume with label backup on /mount/backup with default options and without allowing the execution of binaries from it. So we got to do, so remember, fstab is just a mount. It's just what's fed to the mount command. So without so we can do disallowing binaries. Let's go to the man page. Search for binary. Nothing. All right. Okay. So with a label backup on, so about what default options, and without allowing the execution of binaries. Uh, shoot. Execution maybe. I don't know about this binaries thing. It's obviously an option of some kind. So let's look at the options. And it's a better FS, right? Yeah. Oh, well, that's a problem. All right, so these are mount options 4. So let's try that. We're going to do mount options 4 and then see if we can find the better FS. Nothing. I mean, it's a B, so I think we can actually do a P maybe? No. Okay, we're starting at the A's now. Ah, here we go. Perfect. So what we do is we would do so the first thing we would have is and I'll do it in a notepad. So it would be label equals backup. All right, and then we would have the yeah. So then we'd have the type. It would be I think like that. Unless that comes next, I'm not sure. I think it comes next, so I'll put it next. Okay, and then the default options without allowing the execution of binaries from it. Without allowing the execution of binaries. You know what? I'm just gonna say I don't know. This is what I have so far. So take it or leave it, I guess. And this might be one where the answer is for a different question, which would be unfortunate. Yeah, it looks like that's very much the case. So, so it looks like it's the same. So write as slash sc/fstab entry that would mount. Oh, you know what? I got this right. Oh no, but I didn't. Yeah. Okay, that would mount better FTS volume with the label backup on /mount/backup with default options and without allowing the execution of binaries from it. So I'm missing the options. Defaults is an option, and then what I was looking for is no exec. Let's look for that. So default should come first because it's in alphabetical order. I don't see it. Yeah, I see. I'm not sure where to look for this. So let's look for defaults. Okay, so use the default options. So here we go. So here's probably where it's under. Yeah, no exec. Do not permit direct execution of any binaries on the mounted file system. So these are under the file system dependent mount options section. For some reason, I can't get a hit on this. There we go. Entry that would mount, and this says entry that would mount and this says entry result that would A. Okay, so that's why. Alright, so second to last, thank goodness. Consider the following system D mount unit. Okay, considering it. What would be an equivalent /fc/fstab entry for this file system? So this one I should be able to get right. So this is not the label, this is the description. So the one thing we could do is UUID. Okay. Should be able to get this one right. And then the mount point, which is external. Alright, and then the type is NTFS. Okay, and then the options, which are just the defaults. So here's my answer, and I'm sticking to it. In fact, I might even see if I get a hit on that. I do, okay. So I got it so right that I could Control F. So the entry would be, again, the entry would not be this. I think this is a typo. They're just trying to abbreviate it. Maybe that is a shorthand to just give the last part of the UUID syntax, but as we saw in the RFC and everywhere else, this is not a valid syntax for UUID. But yeah, everything else got it right. So hopefully the LPIC itself has a lot of questions like those, because that was not too challenging. All right, so the last question, thank goodness, is what should be the file name for the unit above? So probably this unit here. Yeah. So it can be used by system D. Where should it be placed? So the file name. Oh, I see the file name. I forget. I just absolutely forget. So I'm not gonna look at the answer. Oh, it should be a dot mount. So, and it should be in /etc/systemd /system. So it should be like something like the file name should be let's go with like external.mount, and then it should go in /etc/systemd/system, and that's my final answer. So the file name must be the same as the mount point. So yeah, oh, the same as the mount point. Okay. Placed in /etc/systemd/system. So I got that part right, even though I cheated and looked. But I got the file wrong. I thought it should be external.mount just based on like what the mount point was. But the real answer is that you have to name it after the mount point, which is like external. Oh yeah, so like you would do mount dash external.mount is like how you would form the name. All right, so that's it. Thank goodness. What are we at the 2-hour mark again? 1:30. That's not so bad. So here's the summary. In this lesson, you learned how to mount and unmount file systems manually or automatically. Some of the commands and concepts explained were mount, which mounts a file system to a location. Umount unmounts a device. LSOF lists the processes accessing a file system. /mount and /media directories. /etc/fstab. LSBLK lists the type and UUID of a file system. How to mount a file system using its UUID or label. How to mount a file system using systemd mount units. And how to auto-mount a file system using systemd mount units, which I kind of forget. Okay. So you do mount units. That's where we just did. Mount units are these files here. So you create these files, then you start them with systemd, and it will auto mount like that. All right, so that's it. We're moving right along. Exciting times for sure. So that's it for lesson .3. So stay tuned for .4, which is managing file permissions and ownership. And I'll just get to it by this is the surefire way you get to it. Oh, and actually we got some good news. There's some sort of thing happening where there's no longer .4, so we got one for free. Hooray. So stay tuned for .5.